Now let me discuss about the title of the process. Our title is Application of Classification Algorithms for Analysis of Road Safety Risk Factor Dependencies. The main objective of this paper is to analyze the road safety risk factor dependency in road accident data using classification algorithms. In order to overcome the limitations of regression models, classification models of data mining approaches have been applied to the risk factor analysis problem. Among the classification models, the Bayesian classifier and the decision tree classifiers are used. Now let me discuss about the abstract of our process. Transportation has literally converted impossible ideas into amazing realities. Transportation, however, comes with accidents that create mild into fatal injuries, and reducing the fatalities and injuries of road traffic accidents has long been a concern for governments and the general public. In most of the existing studies of risk factors, the data are categorized according to the accident severity level. For instance, fatal, severe, slight injury and property damage only. The other data fields can be used to model or estimate the severity level, and the modeling or estimation allows a common and effective way of evaluating risk factors. In order to overcome the limitations of regression models, classification models of data mining approaches have been applied to the risk factor analysis problem. A classifier is a function that classifies the class variable given a set of input variables which are called a feature or attribute variables. Typically, severity level is a set as a class variable and risk factors are set as a feature variables. Now let me discuss about the data flow diagram of our process. First, our process is under the domain called data mining. So we have our input is a data set. First you have to select the input data. After you select the data set, you have to convert the data set into CSV. Our input file is CSV. After you select the data set as a CSV file, you have to convert that file into the ARFF, that is called attribute relation file format. After that, we convert that file into the AR format. We have to select the features for our process. Feature is nothing but an attributes in the data set. After we select the features in the data set, we have to remove irrelevant features. After we remove the relevant features, we are going to implement the classifiers for classifying the accidental analysis for analyzing the accidents. Here we are implementing the two types of classifiers. They are called as decision tree and naive Bayes. So in that naive Bayes, we are using some conditional probability formulas. By using some conditional probability formulas, here we are going to find out the information gain entropy, and then gain values. By using that gain values, here we are going to classify the results of the data set. After that, we predict the results by using naive Bayes. Then here we are implementing the decision tree also. So by using the decision tree types, such as here we are calculating information gain, entropy, then Gini index, Gini ratio, then gain ratio, information gain. These type of parameters are calculated here. By using the type of parameters, here we are calculating, we are classifying the results. After that, here we predict the results by using decision tree. So after we predict the results of naive Bayes and decision tree, here we are going to compare the two types of classifier results. Here after that, we evaluate the performance of both decision tree and naive Bayes, and after that, here we are evaluating the results by using the ROC curve. In that ROC curve, we are calculating the false positive rate, true false positive rate, like that. By using the type of parameters, here we are going to evaluate the performance of existing system and proposed system. This is the data flow diagram of our process. Now let me discuss about the complete demo of our process. First, you have to run home.java. Our title is Application of Classification Algorithms for Analysis of Road Safety Risk Factor Dependencies. Then click Next button. So here you have the data set loading and extraction process. Here you have to choose your data set. After that, you choose the input file. You have to convert the data set into the AR format. So here we are extracting the data set as a AR format, converting the data set to CSV file as a AR format. So here we are extracting the relation name, attribute name, and data set. Then after click create table, table has been created successfully in the database. After that you have to extract the data. So data are extracted in the database. So loaded data in the database. So here we are going to apply the pre-processing mechanism. So here we are calculating the median value for applying the null values or unwanted symbols calculated. That missing values are converted into the symbol and symbols are converted into the median value. So pre-processing is successfully finished. Then click next button, click view. So here we are applying the median value for that missing values. Then data cleaning, clean the data, results are classified. Then here we are viewing the attributes in the data set. Here we are calculating the standard deviation for every attribute in the data set for estimating the neighborhood relationship of an object. After you standard deviation has been calculated, then click view. This is the standard deviation calculations for every attribute. Then click next button. Here we are going to apply the new Bayes algorithm. So datums are cluster, show cluster. So based upon the values of accident levels, here we are calculating the 3 types of clusters. Then here we are calculating the conditional probability formula. So P of A conditional B, this is a P of A intersection B. P of B conditional A equal to P of A conditional B divided by P of A intersection P of B. So this is the formula for calculating the new Bayes. Then click next button. By using that new Bayes formulas or values, Bayesian values, here we are calculating the matrix information gain, entropy, and then gain values. After that we get the information gain, main matrix, entropy, gain values. Here we are classifying the data sets. So here we are calculating the matrix and information gain values by using that new Bayes values, probability values. Here we are calculating that values and get information gain, entropy values. Entropy values has been calculated based on matrix and information gain. Entropy values has been calculated. Then gain values has been calculated for 3 types of clusters. Then click classify. Then predictions, here we are aggregating the results. Then click next. Here we are predicting the results based for every countries. Then predict the result. So here major accident placed in a corporator. Then medium accidental analysis are in these types of countries. So this type of ranges, by using that type of ranges, here we are predicting the values. This is an A-based implementation. Here we are going to implement the decision tree. So first you have to select the data set. So after you select the data set, here also you are going to convert the data set into AR format. After that you have to create the table in the database and extract the data into the database. Data has been extracted and loaded data, then classify. So based upon the labels classified here, then attributes in the data set. So after that you have to click the decision tree. Here we are calculating the information gain for every attribute, total number of classes. Then for every type of classes, here we are calculating information gain. Bound for information gain values has been calculated for every attribute. We are calculating the information gain. Then after that you have to calculate the Gini index value for every attribute. Then bound for the index, then Gini ratio. Then here we are splitting the info values. Then here we are have an attribute, then information gain, split info, then gain ratio. Then click Gini ratio value. Here we are making the decisions for attribute A0, A1, A2, A3 until all attributes in the data set. Then click free. Here we are calculating the classifying the results based on the trees. Here we are estimating the results low and high ranges. Based upon this, here we are predicting the accidents based upon the ranges low and high. So after that you have to going to evaluate the performance of the decision trees. Here we are calculating the ROC curve, RTPR, FPR, recall values, precision value, F measure value. By using that type of values, here we are evaluating the ROC curve. Then click graph. Here we are evaluating the precision recall values and precision recall values based on the ROC curve in and graph. This is the complete demo of process. Thank you for watching.